So this is another simple way of solving integration by part questions. And this techniques was taught by my lecturer, who is Dr. Haidar Ali Segu from India, from my Signal and Systems class, and is an effective way, or one of the effective ways of solving an integration by parts question without stress. So let's quickly apply it here. We are going to use same example as we use for the tabular approach, and that's example that we use for the tabular approach was x power 3 exponent x dx, x power 3 exponent x dx. So that is the integral of let's go here, let me undo it, integral of x power 3 exponent x dx. So having this, the formula that we use here is, when you get question like this, the technique is integral of, just represented by u, and then you choose your v, dv, or uv. Here we don't have our u and we don't have our dv. We don't have our u and we don't have our v. What we have is u and v. We don't have dv. So choose them here. And what we need to do is that when you do something like this, you are going to get integral of u v dx is equal to u v1 minus u prime v2 plus u prime prime v3 minus u prime 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 v4 plus u prime 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 v5, and so on. So this is the trend, this is the formula. It's u v1 minus u prime v2 plus u prime prime v3 minus u prime prime v4 plus u prime 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 v5, and etc. You can go and go. So based on this, let me explain what each of the terms mean. Let me explain what each of the terms mean. The v1, v2, v3, v4, v5, and so on are the integration of v, or the integrals of v. It's more or less similar to that of the tabular approach or the normal integration by parts, but it's another quick way that someone can learn to solve integration by parts. And then the u1, or u prime, this is not u1, u prime prime, u prime prime prime, and so on. So as we can see from here, when you say u prime something prime, it's all differentiation of u. So when you are given a question like the x power 3 exponent x dx, instead of using the integration by parts or the tabular approach, you can use this simple trend. The first one is uv1. The u is the function, the u function here, and the v1 is the integration, right? The integration of the v. As you can see, here is u and v. So u, and then from there minus, plus, minus, plus, minus. So it's kind of more or less emphasize what we did earlier on, that the trend has been taken into account already. You don't have to now come and just get to bring the sign over here. It has been taken into account already over here for this technique. And then from here, for if you are given the function x power 3 exponent x dx, quickly you write here, which is what? X power 3 exponent x dx Here is our u, here is our v. So using this technique formula, what we are going to do is x power 3 and then integral of v1 which is the v1, its exponent x, minus differential of u is 3x squared, and then integral of v, which is e power x, is still e power x, plus the second derivative of u, which is what? That means this one, 6x again, and then the v, 3, is another integral, which is e power x again, minus the third differential of u, which is another 6, and then the integral, which is v4, we are going to get what? The same exponent x. And then when we find the fourth integral, a differential of v, we are going to get 0, because 6 differential of 6 is 0. So that is plus 0, and then the integral is still giving us exponent x. So as soon as when we reach 0, we need to stop the iteration, and therefore our final answer is x power 3 exponent x minus 3x squared exponent x plus 6x exponent x minus 6 exponent x. So this is our result. So this is as simple as that, and it's a quick way of solving integration by parts question with that, depending on any other means, or it's a quick way of just solving it right away and then you go on. So this is another approach that you can use, the very simple one, and you can try this one on other questions that you may encounter. So in summary of integration by parts, the integration by parts formula is the reverse of, as I said earlier, on the product rule for differentiation that we have done in your calculus 1. And therefore I must emphasize that the choice for the u and then the v, if you are using the first approach, should be such that the integral of that function, which is the v du, it's simpler. That's the additional term which is being added to the actual term from the formula, u dv equal to uv minus integral of v du. So it is being done, or this one is being chosen in such a way that when you are done with the right hand side, this additional separate term here should be simpler than this original term that you are integrating. So if this does not turn out to be so, then you need to check out the values that you assign, or the variables or the function that you assign for your u and your dv, and come back again. The tabular approach is also another useful way of solving a repeated integration by parts, and it's very necessary, so you have to keep it on the fingertips. And I also show you this simple approach, and this simple approach also deals with the integral of u v dx. So it's the only matter of choose your u and v, like the way you do for your integration product rule, and from there you use this one, u v1 minus u prime v2 plus, where the u, it's the representation here, your v1 is the integral of the v, u prime is the differential of which, v2 is the integral of v1, so you get up to where you need to stop the iteration, and I've demonstrated that over here. This is a very simple approach, so do well and practice them, and I know that you have no problem in solving all integration by parts questions. Thank you for